Let f of x equal 2 over x plus 1 and g of x equal 1 over x minus 4. First, let's find g of f. G of f of x. The outer function is g, so we'll write that as 1 over x minus 4, but instead of writing an x, we want to replace the x with f. That is 2 over x plus 1, then we have minus 4, finishing off g. We don't want to leave it like this, though. We have a complex fraction. We need to simplify that. So what we're going to do is we're going to multiply the numerator and denominator of the big fraction by the smallest denominator, that is x plus 1. So we're going to multiply the top by x plus 1 and the bottom by x plus 1. The numerator is pretty simple. We just have 1 times distribute with x plus 1, and we get x plus 1. The denominator is a little more involved. We have this x plus 1. When we multiply this x plus 1 by the fraction, the denominator and this x plus 1 cancel or reduce each other, leaving us with just 2. And then we have to distribute the x plus 1 with the negative 4. So negative 4 times x is negative 4x, and then negative 4 times 1 is minus 4, or negative 4. Simplifying a little more, we get x plus 1 divided by negative 2 minus 4x. And now we've simplified g of f. We now want to find the domain of g of f. Notice it's a rational function, so we set the denominator equal to 0, 2 minus 4x, set that equal to 0, and solve. Add 2 to both sides, and then divide by negative 4, and we get that x is equal to negative 1/2, or in this case, not equal to, because it's a domain restriction. Recall, whenever you're finding the domain of composite functions, we also want to look for any restrictions with the input function. It's easy to forget that. Go back to the input function, that is f, and look to see if it has any extra restrictions. Notice it's also a rational function, so we need to set its denominator equal to 0 and solve. We get x equals negative 1, or not equal to, since it's a domain restriction. So we actually have two problems with domain, negative 1/2 and negative 1. So the domain is negative infinity up to negative 1, union negative 1 to negative 1/2, union negative 1/2 to infinity.